put option, so we hold both the share and the put option, and then at expiry, the value of that portfolio is the value of the share plus the value of the portfolio, value of the put option. So that equals, of course, the share value plus the max of k minus st and 0. That's the value of the put option. So that is equal to then, it's either st plus k minus st, which is just k, if st is less than k, or less than equal to, and it is st plus 0, which is just st, if st is greater than k. Okay? So depending on which part of the option you've got, that's what the answer is. So the thing that we can conclude therefore, though, is that st plus pt has to be greater than or equal to k. All right, why is that? Well, it's certainly equal to k here, if st is less than k, and it's equal to st, but st is greater than k in this other case, so therefore it has to be greater than or equal to k in both scenarios. Okay, so that's certainly the first idea, that at expiry that's the case. So then the conjecture is that at time t, you have st plus pt must be greater than or equal to k e to the minus r t minus t. So why is that? Well, it applies that rule of thumb that I say wherever you see a k, you basically stick in a discount factor back from expiry. So st and pt then become little s, t, s little t, s little p, will be greater or equal to k e to the minus r t minus t. So the discounted value of the strike price back from expiry. So again, we're going to prove by assuming there does not exist arbitrage, and assuming the opposite, st plus pt is less than k e to the minus r t minus t. Okay, and assume the opposite, i.e. there exists a t such that that's the case, and then showing that this implies arbitrage. Okay, so we'll assume the opposite and then prove that that implies arbitrage, so it violates the no arbitrage condition. So suppose that is in fact the case. So let's suppose that we've got that. Then at that value of t, we start with nothing. Okay? And we've got to remember that you sell the expensive and you buy the cheap. So in this case, that's the expensive one because it's the biggest one. This is the cheapest one because it's the smaller of the two. Okay? So what does that mean? It means sell money. Okay, because that's what k e to the minus rt minus t is, i.e. borrow k e to the minus r t minus t. So I borrow that from the bank. And I use that to buy PT and ST. Okay, so I buy the share and I buy the put option. Okay, so PT plus ST costs me PT plus ST. I subtract the two and I get k e to the minus r t minus t minus pt minus st. So that's the money that I've got left. And because of this assumption here, this false assumption, this thing should be greater than 0. Okay? Pull up 1. Pull up 1. Right? So by 1, that's got to be greater than or equal to 0. So what I do with that is I take that and I invest in the bank. I put that money and put it in the bank. Now at expiry, at time t, capital T, the debt rises to, well, I initially borrowed k e to the minus rt minus t. I've got to multiply it by the debt, the interest, e to the rt minus t. That's the continuous time interest. The total debt rises by that amount. So the debt is now k. What's the value of my portfolio that I'm holding? Well, I'm holding PT plus ST. Okay. Well, that equals PT plus ST. And if I subtract that, what do I get? I get okay, so the value that I've got, sorry, should do it the other way around. Okay, but it's PT plus ST minus K. So that's my net assets plus the cash in the bank. All that too. Okay. So what is my net profit then? Or what net position? Okay, well, my net position is PT plus ST minus K, but we know from here, okay, from this thing here, which is correct, from equation 0, we have PT plus ST minus K is greater than 0, and in addition, I've got the cash in the bank, even without that. But the point is that is certainly greater than 0, which gives me a guaranteed profit. Okay. So the point was I started with nothing and I've gone to guaranteed profit of PT plus ST minus K. Okay? Plus the cash in the bank. So that means that there implies that there exists an arbitrage which violates the assumption so it implies something's wrong, and the only thing that can be wrong here is 1. So that implies that 1 is incorrect, so the opposite of 1 must be true, so that ST plus PT must be greater than or equal to K, e to minus RT minus T. So the opposite of 1 is true. Okay? So that is essentially the argument to prove the lower bound on the put option. So you start off with a bit of a rabbit out of a hat here, but it gives you the absolutely guaranteed inequality that you have at expiry. Then you assume the discounting factor here, put that into the conjecture for t less than t, or t up to t. You then assume that the opposite is true with a no arbitrage assumption, and then you go through and you sell the most expensive side, you buy the cheaper side, so you borrow the money, buy this, you get some leftover money that you put in the bank anyway, But even despite that, when you run through, as you go to expiry, you find that if you hold the put and the share, you can actually sell, you can basically, after you've liquidated those assets, you can pay off your debt, and you've still got a positive amount of money left over, given the values, this is guaranteed, this is correct at time t. And so it's less than or equal to 0, plus the cash in the bank means that you overall have a guaranteed profit. So you could end up in a scenario where you don't get anything here, but with the extra cash in the bank too, that will tip you over the balance, and it means that you've got a guaranteed profit. That means that an arbitrage exists, which violates the no arbitrage assumption. Something must be wrong in the argument. The only thing that is wrong, that can be wrong, is this assumption here, because that's certainly true. So in a no arbitrage environment, the opposite has to hold. Okay. Any questions on that? Right. Let's have a look at some upper bounds. So an upper bound on a euro call. Okay, the conjecture is that the euro call is always cheaper than the asset, or less than or equal to the value of the asset. Okay. Why? Well, again, it's proved by contradiction. So assume arbitrage, assume there does not exist arbitrage. Okay. And assume opposite, i.e. Ct is greater than St for some t less than t. Okay? So I'm going to start with nothing, okay, at t. And so what am I going to do? Well, in this case, this is the expensive, and this is the cheap. Okay? So, if you sell expensive, buy cheap, so you sell, i.e. you write one euro call. Okay, that means that you get in your cash in income is CT. You buy the underlying share. That costs you ST, CT minus ST, according to this, is greater than 0. This money invest in the bank. Okay? It's greater than 0 by this assumption here. So then we're at T, at expiry. What is my liability? Well, let's look at my assets. Sorry, my assets. Well, my asset is I've bought the underlying share, so I've got ST in my back pocket, or I can sell it for, at that point I can sell it for the value of the share at expiry. My liability, what is my liability? Well, I've written a call option, so my liability is the payoff of the call option at expiry. So it's max of ST minus K and 0. And if I subtract that all off to find out what my liability is, it's going to be, I'll have to continue over here. So the liability is, it's going to be ST minus K, which is just K, and that's the case if ST is greater than or equal to K. And it's ST minus 0, which is just ST, if ST is less than K. Okay? ST greater than K. And of course, these are both positive. Okay? the share price has to be positive, and the asset and the strike price by definition has to be positive. And I've also got this amount of money in the bank. Okay, so I had that amount left over and I invested that in the bank. So clearly overall, I have something that's greater than 0. So therefore we violate, so I've gone from 0 to something greater than 0, which implies an arbitrage. I've violated the arbitrage, or it contradicts the no arbitrage assumption. Something must be wrong. And if we make the assumption of that there's no arbitrage, the only thing that can be wrong is this thing. So the only thing that can be wrong is 1. So the opposite of 1 must be true, which implies that CT must be less than or equal to ST. So the European vanilla call option has got to be cheaper always than the actual underlying asset price. If you see any time that it's not, you can make easy free money. Right, what other ones have we got here? Upper bound on option prices. Yeah, there's an equivalent European one. On the euro put, sorry. And that one comes out as PT, or PT is less than or equal to K e to the minus RT minus T. And you can go through and read for yourself and prove that to yourself. By contradiction, you can prove a similar argument there. So that's in the notes. The argument is here. You can play with that yourself. Right. One of the really important things that we come across now is put-call parity. So all that we've done so far is to relate the individual option prices to the underlying asset and the and what we got? We got PT is less than K minus T. That's the upper bound on that one. What was the lower bound? So those are the bounds that we've got so far. We've got upper bounds and lower bounds on the European call and the European put options. Okay. What the put call parity does is it relates the values of C to P. Okay. And there's this actually one turns out to be, because it's called parity, this has actually got an equal sign in it. Okay, so this actually definitely relates the European call value to the European put value to the underlying share price and the strike price by an equality. Doesn't allow us to determine individually what CT or PT is, but if we know one, this put call parity can tell us the other. So this argument runs in a similar way. I'm going to consider two scenarios, A and B. I'm going to hold a portfolio which is a call option plus an amount of money K e to the minus RT minus T. That's part A of the portfolio. Part B, a separate portfolio, is a put option and the underlying asset. Okay? Now, at time t, at expiry, what have we got? What is the value of this portfolio, and what's the value of that portfolio? Well, the value of that is it's CT plus K, okay, because the T equals capital T, so this just becomes CT plus K, which is then the maximum value of ST minus K, 0, added to K. So that equals ST minus K plus K, which is ST, or ST greater than or equal to K, and it equals just K, or 0 plus K, which is K, for ST less than K. So that's the value of portfolio A. If I now look at the value of portfolio B, at expiry it's PT plus ST. What's the value of PT at expiry? It's the maximum value of K minus ST and 0. The value of ST is just ST. If I see what that equals, well, for ST greater than K, this is 0 plus ST. So it's ST for ST greater than or equal to K. And for ST less than K, it's K minus ST plus ST, which is K for ST less than K. And now, lo and behold, those two portfolios have the same value at expiry, whatever the outcome. Okay? So those two portfolios theoretically are the same at expiry. So the conjecture is, are they going to be similar, identical at t less than capital T? So, conjecture. We've got the conjecture that Ct plus K e to the minus RT minus T equals Pt plus St for all t less than or equal to T. Okay, so the conjecture is if the value of the call option, or the price of the call option, plus the discounted strike price from expiry is equal to the value of the put option plus the share value, underlying asset value. Okay? These calls and these puts, of course, are all on the same CT and PT. They've all got the same underlying, okay, and the same expiry. This doesn't work if they're on different underlying assets, and it doesn't work if they've got different expiry dates, but it works if they do have the same. Oh, and the same strike. Okay. So this is an equality. So if we're going to prove it by contradiction, so because it's an equality, we've got to prove all the other possible scenarios cannot hold. So there are two things that we actually have to prove here. We've got to prove that the greater than is wrong and the less than is wrong. Because if you can prove the greater than is wrong and the less than is wrong, providing it's okay at the capital at expiry, the only other scenario you can have is equals. Okay? So there's 1 and 2. I'm only going to do 1. Okay, I'll leave twos in the notes as well. You can do, that's going to be an exercise for you. But I'm going to do 1 here. So I'm going to suppose that Ct plus K e to the minus RT minus T is greater than Pt plus St. So this is the expensive, and that's the cheap. Okay, so I'm going to buy the cheap side, cheap side, and sell the expensive. No, buy the expensive, sell the cheap, sorry. Well, you know what I mean. Fine, yeah. Sell the expensive, buy the cheap. That's what it is. Okay. So what that means is at time t, I'm going to write CT and borrow k e to the minus RT minus t. That's this selling bit. So if you sell money, that means you borrow it. Okay? So that on the buying side, so I'm starting with nothing. And then I buy a put option and the underlying. Okay? So what have I got? Well, my assets are, the income, income is, I'm going to write this and get CT for writing it. Someone's going to pay me CT for it. I'm going to borrow this money, and I'm going to pay out PT and ST. So overall, what I get is CT plus K e to the minus RT minus T minus PT minus ST. So my income, I've started with 0, and that's my income at that point, and that must be greater than 0 by 1, okay? Because I've assumed that that's true. So this must be greater than 0, and this money I invest in the bank. So the proceeds I put in the bank. Right, now I wait until expiry of the options. And what are my assets? Well, my assets are, I own a put option, I've got a ST, I've got the underlying asset, which is then max of K minus ST 0 plus ST. My liability, well, what are my liabilities? Well, I've written a call option. So if at expiry someone wants to come and exercise that, I'm going to have to pay them. So my liability is minus CT, and also my debt has now gone up to K. Okay, because my debt rises, goes from K e to the minus RT minus T. I multiply the interest on it, and that gives me K. Okay, so I've now got a debt that I borrowed this amount of money at time little t. When I get to expiry, that money's gone up to K that I owe. So this then is minus the max of ST minus K and 0 minus K. And of course, I've also got here plus money in bank. Okay, which call that star. Okay, so I've got the money in the bank as well. Okay. So this is the money. This is my wealth. I've got money in the bank, and I've got those liabilities. So if I now work out what those are, I've got max of K minus ST. Sorry. So I've got that. Let's just focus on these things at the moment. We'll worry about the money in the bank in a minute. That's what my assets minus my liabilities are, so work that out. It's K minus ST plus ST plus minus 0 minus K, which is 0 if ST is less than or equal to K. If ST is less than or equal to K, the put option value is triggered. Someone's going to ask me, I can go and get some money for the put option. I can get K minus ST for the put option. I can sell my share for ST. No one is going to exercise the call option because all they'll get is 0 because ST is less than or equal to K, and I've got to pay the bank back at K, which gives me 0. On the other hand, if ST is greater than K, well, if ST is greater than K, my put option expires worthless. I've got the share. My call option here, someone is now going to come and ask for some money, and the payoff there is ST minus K. I still owe the bank K, but then if I add all that up, I get 0. So actually, this particular portfolio, my assets match my liabilities, whatever happens. So what happens though, I've got some money in the bank also. I've got this amount of money. I've got that amount of money in the bank, and it's grown by that amount of interest. Okay? And that we know is greater than 0, because this money was greater than 0. Multiply it by a positive number, you've got something greater than 0. So I started with nothing, and I've gone to something which is greater than 0. So although all this playing around with these calls and put options, my overall portfolio was just a very complicated way of ending up with nothing, the extra money that I had at the earlier time, which I then invested in the bank, gave me a guaranteed profit. So I've got a guaranteed profit. So there exists an arbitrage. And the only thing that can be wrong in that argument then is that this thing is wrong. So that one is wrong. So this carries on from here. There. So that proves that this can't be greater than this. You now carry out the same argument to show that it can't be less than this, or a similar argument to show that it can't be less than this. That's in the lecture notes. And then the only other scenario is if you're in a no arbitrage environment, is that equality must hold. So you bound it above, you show that bounding above is wrong, bounding below is wrong, so the only other thing that holds is equal. And ultimately that's where you get the put-call parity. So what does that tell you? It tells you, for example, if you know what the put value is, what the underlying is, and the strike is with the interest rate, you can then work out the call value. Conversely, if you know what the call value is with strike, discounting, underlying, you'll be able to work out the put value. Okay, so put-call parity is a way of, when you know one answer, you can find the other one out. Okay? Now, we don't yet know how to find CT or PT. That's what the rest of the course is about. But in theory, it simplifies a lot of arguments, a lot of calculations, if you can then just play put-call parity. Come to sleep. Right. Okay. So there are other arbitrage scenarios there, forward contracts and forward pricings. I'm just going to leave you to look at that. A forward contract is just where there's a definite requirement for both sides to settle up rather than just a one-sided argument. Here is a really nice example of arbitrage as well. American call options. So if you recall, American call options give you the right, but not the obligation, to buy something at an agreed price at any point between the purchase date of the option and the expiry date. The European call option only allows you to make that decision at the expiry date. Okay? So the American options give you a much longer time scale. So the question is, what is the value of an American option. In general, when we come to try and work it out mathematically, or when we use either Black-Scholes or we use martingale arguments, it's incredibly difficult and complicated to do it. This is the one scenario where an arbitrage argument, well, other than called parity, this is one other example of where you can get a definite answer from arbitrage. Okay, it's not a bound, but you get a definite answer. So the way it works is the following. So I'm going to suppose that there's an American call option. I'm going to denote its price by, I'm going to put underscore just to show it's a capital, because I'm going to use the euro call option is a little ct. Okay, so big C with an underscore underneath it means capital. So that's the American. Okay, and they're on the same underlying. Price ST, strike K, and expiry capital T. So that's, the only difference between them is that they are, one's an American and one's a European. Okay. Right, what is the payoff of the American option? Well, that is max of ST minus K0 for all t less than or equal to t. Okay, the payoff of the European is the max of S capital T minus K and 0, and you can only get that at t equals t. Okay, otherwise you can't exercise it. Right, so what do we know about this? Well, the first thing that we're going to say is we know that little ct is st greater than or equal to st minus k e to the minus rt minus t. So that's for the euro option. We know it's bounded below by st minus k e to the minus rt minus t. That's what we worked out before. The American we know we're going to assume that it's got some value, positive value. Okay? Why is that? We can prove that it's going to have some positive value. So these are the lower bounds. We can assume it's got some lower value. Why? Because if CT were less than 0, okay, what would we do? Well, we would buy the American call. In other words, if it's negative, someone would have to pay us to have it. Okay? So in buying it, we would receive the price of it. Okay? So if the price of the American call option were negative, I would buy it, and then if you wrote it, you'd have to pay me the money. Okay? So if it was negative, okay, I would receive CT, then immediately exercise. I can immediately exercise because it's an American option. Okay, I couldn't do that if it was European, but I can immediately exercise if it's European. And the price would be, the payoff would be 0 if ST was less than K, and it would be ST minus K if ST were greater than K. Okay? But that then is clearly greater than 0 for all ST. It's clearly greater than or equal to 0 for all ST, because here it's 0 and here it's ST minus K when ST is greater than K. So it's going to be positive. So the profit then is then, well, it's CT plus 0 for ST greater than K, because I've received that money just now, and it's CT plus ST minus K, that one, which again is going to be, which is greater than 0 for ST greater than or equal to K. Okay. Because this is positive, and this was a definite value I got. Minus CT. Yeah, so it's minus CT and minus CT, that's right. So this is positive overall, and that's positive overall, okay, because I received that. So overall, I get something positive. So this looks, this basically, I go from 0 to something greater than 0 for all possible values of ST. Therefore, there exists arbitrage, ... violation of arbitrage. That has to be wrong. Okay, so that basically proves this thing here. So the value of a call option is always greater than or equal to 0. Okay, so now here comes the neat bit. Okay, so next point then is flexibility. Right, anything you can do with a European option, you can also do with an American option. And watch the order. Anything you can do with a European option, you can do with an American option. So, European option, really, you can only do something at expiry. Okay? Clearly, if you've got an American option, you can exercise at any point up to expiry. You could just wait and then exercise it at expiry. So so you can certainly do anything that with an American call, but of course, there exists more flexibility in American. You can exercise early. So if you exercise early, you've got greater flexibility in the American, you've got greater privileges by holding an American option than you do holding a European option. To get those extra privileges, that will cost you money. Okay? There's an extra value in holding an American option, theoretically, over a European one. So, extra privileges, I can't spell privileges. Extra privileges mean you should expect to pay more. Or at least as much expect to pay at least as much as the European vanilla call option. The other thing I've not said here is this is an underlying doesn't pay, it's no dividend paid, sorry. That's the key assumption as well, sorry. Right. So the extra privilege means you shouldn't expect to pay as much as that. So the point is that CT must be greater than or equal to CT. So that's the next point. Right, so now we know something about CT. We know that CT must be greater than or equal to ST minus K e to the minus RT minus T. That's what the lower bound is here. Okay? Now, that has got to be greater than, for t less than t, that's got to be greater than st minus k. Why? Well, for t less than capital T, this number is less than 1, so you're subtracting off less than k from st. So if you do subtract off k, you're subtracting more off st than you are here. So this has got to be a greater than here. But we also know, though, that we've got that argument too from here. Okay. So that tells me that Ct must be greater than St minus k for t strictly less than t. So that gives me a lower bound on the European American call price for t less than t. Now this is the really crazy bit. So here's the crazy bit. What am I going to do if at time t, st is greater than k? Now, I have a choice with an American option to keep that option in my back pocket or to exercise it, right? If I exercise it, what do I get? If I exercise it, if st is greater than k, I get the max of st minus k and 0, which is st minus k, if st is greater than k. But from here, we know that's less than the price of the option. Strictly less than, sorry. If st is less than k, then the value I would get from exercising the option is 0, because I don't get anything. It's worthless, that option at that point, from exercising. But I also know that's less than the call option from here, or strictly speaking here. So, what does that tell me? There is absolutely no point in me exercising this, because I could sell that option at that time for more money than I could get by exercising it. If I exercise it, I would realise st minus k, but the argument showed that that's less than the money I could sell it for. If I exercise it in this scenario, I get nothing, which is, again, less than the value I can sell it for. So because the intrinsic value of the option is less than the price of the option at that point, no one's going to buy it from me. Okay? So no one will buy it from me. So there's no advantage in early exercise or even selling it before expiry. So I keep until expiry. There's no advantage in selling it beforehand because I'm going to get less money than I could by selling it on, and no one is going to buy it from me. I might as well keep until expiry. So I keep it until expiry, and so then I might as well just hold a euro call. Because if I hold that thing until expiry, it's just the same as holding a euro call. If I'm only going to exercise at expiry, I could have just bought a euro call. So if there's no arbitrage, then that must imply that the value of an European call option is the same as the value of an American call option. So there's no advantage to early exercise. This only works if you've got an underlying asset which doesn't pay a dividend. If you've got a dividend in there, it messes that argument up because you're getting money in the meantime. But the general argument is better expressed in the notes than on the board. But the argument is there. So essentially, there is really no advantage in exercising early. So the value of an American call option is the same as the value of a European call option. The same is not true for the put options. For a put option, the European put option will cost more in general than the European put option, but that's a different argument. But that you can prove this one easily with no arbitrage. Right, that is arbitrage. What happens in reality, as I said the other day, is there is arbitrage. Okay, people's job is to find where these tricks and money and arbitrages exist. So you'll be looking for put call parity imbalances. The other thing we've not taken into account here is the bid-ask price spread. So when I can eventually get a computer in this university to work, I want to show you the derivatives option listings on the real exchanges, and you'll see there's a bid-ask spread. So there's not one price for the option. There's the price you can buy it at and the price that you sell it at. And that's essentially the profit that the market makers are going to make by doing that. But nevertheless, these theoretical arguments exist. In practice, all bets are really off. Most of the time it'll be difficult to make an arbitrage for other reasons, but in practice they are.